Okay, welcome to the sixth session. Today we will just review the statistical tests together, and we will move on to do like an introduction to association measures, and after that we will go to data entry again and how to do data entry practically, and how to deal with databases. Okay, dealing with databases will have two parts, just a simple part this session and the longest and most difficult part in the next session. So please, starting this session, we will need to try. Please just don't listen to the session and stop afterwards. You need to try everything you are learning, because those mistakes I did before and I'll tell you about, you won't remember them unless you get into them. Okay, so you ready? Everything is fine? Please just thumbs or okay. If you remember, yeah, the statistical tests, we use them according to different questions. Okay, first question is, what is the type of data? If the type of data is categorical, we will use chi-square. Okay, sometimes we will use a test called exact test. Okay, there are several tests, but the most common one is chi-square. If it is continuous, then we will have we will have the option. The first option is to do relationships. If you remember, a scale and a scale, two continuous variables, and we need to know the relationship between them. So we do regression or correlation, and the correlation tests are Prison or Spearman tests. Okay, if the differences, if you want to just know about the differences, not the relationship, the differences mean that, okay, they are affecting each other or they are not affecting each other. Okay, if we need that, we will take one of two options. The first one is if we have a single mean. Okay, we compare it to the mean and the characteristics of the normal population. And here we have one sample t-test. The second part, we will have several means in our sample. Okay, so several means means I have two or more. Okay, if I have two groups with two means, then I will have to answer that question. Are the data parametric, meaning they have normal distributions or not? So if they are yes, we take the student t-tests, the two sample t-tests. If they are not, we take the man with me. Okay, but before we take that, we try to transform data. Okay, transform data, it's like changing the data in a specific way to make them normal again. If they are right skewed or negatively skewed, we make them normal again. Okay, so those are our options. And if we have more than two groups, we will do ANOVA test. And in the same situation here, we'll do the ANOVA test and try to transform the data, if they are not parametric, to do ANOVA test instead of Wallace test. Okay, now we will go to the papers. If you remember, we had a folder full of papers, and you can choose the paper you want, and we will discuss and think about the tests they did in that paper. Do you remember that one of these papers was difficult enough to be discussed right now, or should I take anyone randomly? If you have any paper,
randomly.
yeah, please, Zara.
Apparently, no one has
Okay.
any papers, so randomly.
Yeah, I think starting randomly would be best idea. Then if we have a complicated paper, we can
Okay.
try to add this one.
I'll take this. Perioperative liver function after a hepatectomy in Territorial University Hospital in Damascus. Okay, so let's go to the tables. Okay, here we have INR. Here we have pre-surgery and post-surgery, and we have a number. Okay, here we have a p-value of less than 0.05. So what do you think the test here was? And what was the null hypothesis, and what is the conclusion in here?
Is it a t-test?
It is a t-test. Why?
Okay. Continuous data and
Okay.
I don't know if they are parametric or not, but I'm assuming they are.
Okay. Then it's either t-test or man-Whitney test. But do you know if it is one sample or two sample t-test?
Okay, we have pre-surgery and after surgery, so they are two.
Okay, they are two, but this is a special case. What do you remember the name for this case?
Self-control?
Baird t-test. Baird sample t-test. Okay, do you remember that?
Okay. Yeah,
okay.
Yeah, sorry.
I think the test here is like this. Usually, they put a star here and they put the name of the test under the table, but okay. Look here. They said in the last line of the methods, they discussed the analysis. In the analysis, they said they use the two-tailed and they choose the p-value to be significant if it is lower than 0.05. What did they mean in here? They said that the alpha is 0.05 and I'm comparing the p to the 0.05. So the confidence interval will be 95%. Okay. Data analysis will be performed by SPSS, chi-square to compare categorical variables, t-test to compare continuous variables. Okay, we will take another example. Those are all laboratory tests, so they are all the same. And this is why they didn't mention the test. Actually, usually, if we have different tests, we should mention them. But here, they just put that note here, and they just continued with the same test. But if we go to here, okay, we have sex, and we have the sex different proportions for anatomic and non-anatomic hepatectomy. Okay, so here we have a p-value, and this p-value is not significant, if you agree with me. So what should be the test here?
Chi-square.
Chi-square. And what should the chi-square? The chi-square, we say that chi-square goes to the normal percentages and compare the sample to the normal percentages and tell us if they are different or not. Okay, so what do you think the normal percentages in here?
That there was no difference between both groups, like
actually now we have two groups, anatomic and non-anatomic, and we have females and males. So the difference will be if I do more anatomic for males than in females, that would be interpreted as significant by the t-test, by the chi-square test. But if I do as many anatomic resection for females as I do for males, then he will consider this by chance. Okay?
Ah, that is what I said, that there is no difference between both groups.
Exactly. Okay. So this paper is so easy. We will take another one. Okay. Let's try this. This is a systematic review. We shouldn't take this. A randomized trial. Effect of early corticosteroid treatment on a type of coronavirus. Okay. Here we do not have any p-values. They just reported numbers and confidence intervals. We need p-values. Oh, no p-values in here. RC. Here we have sensitivity and specificity, and we will not discuss this diagnostic criteria in here. Risk factors for back pain in Marines. Okay, I remember this was difficult. If you remember, this was a cohort study. Okay, so here we have means and the standard deviation, and this is table 1. No comparisons in here. Okay, here we have some tests. I hope you can see my screen well enough. Okay, let's start with this p-value.
Ahmed.
Yeah, sorry,
Ahmed was asking if we can use confidence intervals instead of p-values.
Confidence when I'm reporting a number, I report it with a confidence interval. Okay, but if I'm comparing two groups, I can tell you, if I tell you, for example, I have one group with a confidence interval of this and another group with a confidence interval of this. Okay, you need to consider that and think about it. If the two confidence intervals are like overlapping, that won't be significant, but if they are just overlapping to a very little extent, that might be significant, because the mean in here is still out of the confidence interval in here. Okay, so I can do that, but it's not accurate. And consider it, if I tell you just one number, a p-value that should be compared to 0.05 is easier, or telling you about two confidence interval and letting you decide which is bigger and if they contain each other and so on. Okay, so I don't think anybody prefers that. Okay, here we have body weight, lower and higher, and we have number of cases with no back pain. What should be the test in here?
So we are trying to know if there is any, let's say, if the weight causes the pain, it's a correlation or something.
Yeah. Okay, the first question is, what is the type of this variable, body weight? What do you think is the type of this variable?
Continuous.
It is continuous. Am I dealing with it as a continuous variable?
No.
Okay, so it is continuous, but I divided it into two groups.
Yeah.
Two groups.
Dichotomous.
So, well, dichotomous, yeah, exactly. Okay, and for here, for the cases, we have cases and no cases. They are not reported here, but we have the total number and the cases. So we have yes and no, right?
Yeah.
So dichotomous and dichotomous. So what should be the test? Yeah. Okay, let's start. Okay, we will take examples about each one of those explanations for associations. First, if I tell you that people with epilepsy have higher CRB than people with strokes, okay? But after investigations, you find out that the tests for epilepsy patients are sent to different labs from those with strokes. So this is an association, okay, and I might have a significant p-value, but the reason is not the disease. The reason is like there is systematic error. The machine in that lab is different from the machine in the other lab, and they are getting higher CRB because just of the different reference range for each device, okay? For random error, this actually can't be explained because if I take a sample of my population and you took a sample of the patients in Syria and another doctor take a sample of patients in Egypt, okay, and we can find out that the variability of patients in Germany, for example, are higher, and we didn't get any significant p-value. But in Syria, there is no variability between patients, and they get a significant p-value and a significant association between two things, okay? So this can actually be just happening randomly because of selection differences between two countries, and that's why when we repeat that study or that test, we will find out that that was actually just a random error. When we are saying a p-value of 1%, for example, 1% is lower than 5%, and I accept this is a significant, and I reject the null hypothesis. But this actually has the risk of 1% of receiving my association by chance, okay? If you remember that, you understand that in every p-value, I have that chance, and it can be my study, that chance. Okay, so even if it is 1 per million, actually my study can be that 1 per million, a chance of random chance that is affecting and giving me an association which is actually false. Confounding, for example, if I'm telling you that I took a sample of patients and I found out that low back pain cause higher quality of life, okay? So if I tell you that, you think, yeah, they are associated, high quality of life and low back pain. But when you investigate more, you find out that I'm just taking those who are rich, okay? So when those are diagnosed with low back pain, they are sent home to do some sports and to relax and do not work anymore. And yeah, they are relaxed and they have a better quality of life now, just because of different things, not just because of the diagnosis, okay? If I tell you that, no, actually, I took a mix of poor people and I asked them about low back pain, and they found out that, no, they have low quality of life when they are diagnosed with low back pain, then the differences is not actually because of the low back pain. There is something else that is affecting the relationship between low back pain and the outcome. Okay, those poor people, for example, when they are diagnosed and sent home and they can't work, they are stressed by the low income. Okay, so there is something else that I'm not asking about, and it is affecting my outcomes. So these outside factors that I don't control for are called confounders. So what is the best way to control for them? I need to get the information first. Okay, so if I don't know that the socioeconomic status affects quality of life, then I want control for that. But when I know, I collect data about, are you rich? What is the socioeconomic status of you? And after that, I control for them. I control between the two groups, and my study will become, will actually study the causality, not telling me about associations that might be caused by confounders. Retro causality. Do you have any question about those before?
Ibrahim, can you
Yes.
please repeat or give an example about retrocausality?
Yeah, I will talk about retrocausality right now. For example, I did a study in here, and I found out that there is a high flow of patients to the hospitals in March. Okay, and I found out that there is a high prevalence of COVID-19 diagnosis in that month too. Okay, in comparison to February. I can tell that COVID-19 caused people to have to go more to the hospital, and I have more flow in my hospital. Okay, but it might be that people are going to the hospital, and the hospital has a lot of people infected with COVID-19, and people are receiving COVID-19 when they are going to the hospital. Okay, so it might be going to the hospital caused the higher level of COVID-19, not the higher prevalence of COVID-19 caused the higher flow. Okay.
And how would I know that?
With different studies, I need to test more what comes before what. Okay, are people diagnosed with COVID-19 if they are not coming to the hospital too, or no, they are just diagnosed with that when they come to the hospital or when they are admitted to the hospital? Okay, so I need to keep that in mind, that the association I'm getting is not usually, is actually it's not always because of causality. Okay, it can be the other way around. For example, if I'm not thinking about that possibility, I will say no, COVID-19 is affecting people and people are coming to the hospital. But when I consider that other option, that retrocausality can be an option for that association, then I need to do another study. Okay, I'll take a sample of those in the hospital and those who are diagnosed with COVID-19 while being in home, and I will find out more about the outcomes, and I will find out if the flu caused the COVID-19 infection or the other way around. Okay.
So it's like retrocausality is represented by case control studies?
No. Any kind of study can be, any kind of study that gives you association can give you any possibility of those. Okay. So what do you do if I have a cohort? I will do a case control, or I will do an interventional study, or I can actually just do an analysis of the same data I have. Okay, ask more information, ask more about the time course of the event. Okay, so it was just an example, but when I know about the situation, I will need to find out a way to get rid of that explanation of my association. If I didn't succeed to prove that retrocausality can be the cause, then causality returns.
So, in another words, retrocausality is like not a true causality.
Yes, yes.
Okay.
Retrocausality is saying like not the way I'm thinking. COVID-19 caused higher flow. No, it's the other way around. Higher flow caused the higher incidence of COVID-19. Okay, so now here we find a cohort study. When a cohort study, I follow people forward, and in a case control study, I go backward. But what is the difference in the measures of association? When I'm talking about a cohort study and I'm following forward, I'm taking a group of a group that is representative actually of the population. Okay, what do I mean by representative of the population? I mean, I'm taking a city out of Syria. I'm taking a hospital out of several hospitals. Okay, and I'm reporting what is happening for that hospital. But in case control study, I'm selecting some patients and I'm selecting some controls. So we can say that case control study represents the population, okay? Because in the population, I won't find 20 cases of 20 people with rheumatoid arthritis and 20 people without rheumatoid arthritis, okay? That is far higher than the normal distribution. But in exposed, not exposed, I can find out that half of the inhabitants of my city are smokers. Okay, so this difference between case control and cohort study caused different interpretations in numbers. When I'm talking about a cohort study, I can say the risk of something. Okay, risk of something like the probability of risk. Okay, risk means how, for example, if I tell you that the risk of something is 20%, okay, the relative risk of something is 20%, then you understand that those with that exposure will become infected or will become with the outcome in 20% of the cases. But if I tell you the odds are something, then you think just about the probability. If I am in that group of cases, I will have higher probability than the group of controls, okay? So we need to think about them in a different way. The relative risk is different from odds ratio, and the calculation for them is actually different. Why? Because if you, as you remember, for odds ratio, we use case control studies. I just take those who are who have the exposure and the outcome and divide them by those who do not have the outcome but have the intervention, okay, or the exposure. But in the other way, when I'm talking about risk ratio or relative risk, this means relative risk, I'm taking those with depression and I'm dividing them on the total number of those with intervention. Why? Because those total in here in risk ratio in cohort studies represent the population. So I can take that as a risk, okay? But when I'm talking about a case control study, I'm just talking about a probability. The probability in here and the probability in here, but the total means nothing, okay? Is that clear? The total means in cohort studies because cohort studies are representative and the total is the population, okay? But the total in odds in odds ratio, I mean in case control studies, the total doesn't mean anything. 20 cases with rheumatoid arthritis and 20 controls, and the total is 40, and this 40 means nothing, okay? But 100 patients, 100 inhabitants, half of them smoke and half of them do not smoke. The 100 is actually representative of my city. So I can use that and I can take the risk. Otherwise, I will use just the probability in here and the probability in here, and I will tell you that this is an odds ratio. Is that clear?
Yes.
Okay, perfect. Okay, here we will calculate. Here we have an intervention, here we have a disease. In cohort studies, I will divide A, people who receive the intervention and get the disease, on the total of those who receive the intervention. Here on odds ratio, I just take those who receive the intervention and the disease on those who receive the intervention without receiving the disease. There is no plus sign in here. Okay, what is the meaning of relative risk or odds ratio? I have that number, and if you see here, that number can't be 0, because meaning 0 means that the probability in one of these cells is 0. Okay, so it's usually between 0 and the infinity. Okay, but what is the reference? What is the start point? The start point is actually 1. But why 1? If you see here, if I tell you that odds ratio is 1, that means that odds of depression with intervention equals odds of depression without intervention. Okay, because the outcome is 1. And if the odds equals odds here, then there is no difference between those with intervention and those without intervention. And the same applies to risk ratio. Okay, so the reference is 1. 1 means there is no association. Okay, both groups have the same risk. Higher than 1 means that the number with the intervention is higher than the number without the intervention. Okay, the number that I gave them, the exposure, the intervention, whatever, is higher, means that the outcome is happening more than the intervention is causing the outcome. Okay, if it is lower than 1, then I know that not giving the intervention will cause a higher outcome. Okay, so here it applies when that is an exposure. Okay, for example, smoking, I have a lower than 1 value. Why? Because not smoking causes higher quality of life or a better condition. But when I have, for example, an intervention that is beneficial, I should get an RR that is higher than 1. Why? Because when I give them the intervention, I should get a better condition. Okay, but remember that for my example, I said that the outcome is a good thing. But when I'm telling you that the outcome is mortality, then you should consider them the other way around. It's better to have an RR of lower than 1 when the outcome is mortality or anything that is negative. Okay, so we should discuss or explain about RR after we get a look at the exposure and the outcome. Can the RR and OR be the same, or at least like close to each other? Yes, actually, sometimes they are close to each other. But when when I have a very rare event. Okay, for example, in this situation, I have an intervention, and this intervention causes depression or saves people from getting depressed. Okay, and I have a control without my intervention. So, but actually the depression but depression is not very likely to happen, just 2%. Okay, I will calculate the odds ratio. The odds ratio is 2 on 98. I'm just calculating the first part of the calculation. I need to just divide this by 4 on 96. Okay, I'm just taking that number for the first part. And if I take the risk of depression, the relative risk, okay, I divide 2 by 100. So if you see those two numbers, they are really close to each other. But when the outcome is really frequent, I have a very high level of depression when I give the intervention or when I do not give the intervention. Then see the difference in here. It's 80 on 100, it's 80 on 20 for the odds, or 80 on 100 for the risk ratio. And you can see the difference here is far away from the similarity in here. Okay, this odds is higher than 1 and this risk is lower than 1. You can see it, so they crossed the 1, which is the reference number for odds ratio and relative risk. So yes, when we have a rare disease, it doesn't matter if I take an odds ratio or a risk ratio. But when I have a common disease, I should take the risk. Why? Because when I have a common event, I usually use cohort studies. Okay, and by cohort studies, I usually take risk. When I use case control studies, I usually take the odds, and this is for rare events. Okay, those are relative. The two numbers we discussed are relative. Why relative? Because I'm dividing the probability of something on the probability of the other thing. Okay, but this is actually hard to understand. If I tell you the relative risk is 0.5, you understand that the probability of getting the disease while being on that group is half, while the probability of being on the other group might be 1. Okay, so if I stop smoking, I will be like 50% less likely to get a cancer. Okay, but this is actually a difficult number. What is an easiest way? What is an easy way to discuss that? I have those exposed and they have a higher risk level, and I have those not exposed and a lower of risk levels. Okay, and this is actually a normal representation of this, for example. Okay, we have here a proportion and here a proportion, and I'm just representing them here in that chart. So we have that rectangle, and this and those patients are actually the difference between exposed and not exposed. Okay, but we won't find in any variable that not exposed are 0 and exposed are 100. Well, we don't find this case. It's actually like 20%, 25%, 20%, 30%. Okay, so we have that number, and that number is actually just we put the probability minus the probability of something else, and the number we get is either attributable risk or absolute risk reduction. And this depends on the outcome. If the outcome is a risk or something harmful, and I'm telling you I'm putting something harmful, or people are smoking, or people are drinking a lot of alcohol, or they are not exercising, okay, then I have a higher risk, a negative outcome, okay, then it should be the attributable risk. Probability of disease among those without the intervention, I'm not saving them, minus the probability of disease who are treated, okay, who stopped smoking or who started to play sports, okay. So here we use attributable risk for negative outcomes, and absolute risk reduction is the other way around, okay. I give them an intervention, for example, people with strokes will die. So I give them an intervention, and those who will die, the probability of that is reduced. So what is the percentage of that reduction? Is 20%. Then those without the treatment will die, for example, in 40%, and with my treatment, they will die in 20%. So the absolute risk reduction is 20%, okay? If that is clear, we can move on. Please just tell me if you have any questions here. Okay. Here you can find it in another way. Here we have no treatment and a treatment that can stop a heart attack. Okay, so I reduced the probability of death from 75% to 25%. So here, if I'm telling you I need the relative risk, you will take the probability in here and divide it on the probability in here. So you will take 25 on 75, and you will get a third, 0.33, okay? Or the other way around. Okay, if I'm telling you I need a better number for my understanding, you will tell me, if you take the treatment, there is 50% reduction in the risk. Okay, this is actually high. 50% of the cases are preserved just because of this treatment. Okay, what is the number we can get, which can be the easiest number for a clinician, or for a person who is receiving treatment? Actually, there is an easiest number. If I tell you that here we have 100 patients, and 70% are dying. Here we have 100 patients, and just 25% of them are dying, okay? Then, in this case, I rescued 50 patients, okay? So, how many did I treat to rescue just 50 patients? Okay, actually I treated 100 patients to rescue those 50, okay? And this is the number to treat. How many should I treat to rescue one? Or how many should receive the intervention to be preserved from the outcome? Okay, and how do we get this number? If you remember the risk reduction, okay, the risk difference, absolute risk reduction, attributable risk, they are all the same. When we have the minus in here, we can get to the number to treat. But okay, here we have that outcome that is happening 20%, 20 out of 263, and on the other arm 26 per 244. Okay, so I did the minus, and here we have minus 0.03. So out of 100, I rescued 3. Do you agree? The risk difference between two groups Okay, here I have 8%, and here I have 11%. Okay, the risk in here 8%, and the risk in here it's like 75% and 25%. Here we have 8% and 11%, and I just put a minus between them, and here I got the difference. The difference is 3%. So instead of those 50%, the difference is just 3%. So I treated 100 to save 3. Do you agree on that statement?
No.
Okay, perfect. I treated 100 to rescue 3. Then how many do I need to just rescue 1 patient? 100 on 3. Okay, and 100 on here, 100 on 3 will get me 33 point blah blah, but I have a number needed to treat, so I will say 34 patients. I treat 34 patients to rescue 1 patient. Okay, remember that we took the number needed to treat from a risk difference, not from a relative risk or from odds ratio or anything. Okay, I just do the risk difference and take the number needed to treat from it. Okay, we have the number needed to treat and the number needed to harm. Okay, and what is the difference between them? It is just the outcome. If you remember, we use absolute risk reduction for something that is good, the intervention that is preserving people or that are giving us a nice outcome. So it gives us the number needed to treat, just 1 on the absolute risk reduction. On the other way, I have the attributable risk, and the attributable risk, if you remember, gives us a negative outcome, or we calculate the attributable risk for negative outcomes. And if I take that formula to give me the number needed to harm. Okay, so we are done with number needed to treat and number needed to harm. Do you think I need to repeat anything? Okay.
Where do we need to use the number needed to harm? Just please, can you repeat this idea?
Okay. How many people, for example, should go to the hospital to get just one of them infected with TB, for example? Okay, you know that going to the hospital allow a higher probability of getting infected with TB. So for every 1 million who visit a hospital, just 1 get infected with TB. Okay.
Okay. The definition of the number, not
exactly.
Okay.
Exactly. Okay. Here we have that that chart, and that chart is actually named Kaplan-Meier. Kaplan-Meier say that we start with 100 patients, and after a while they will die, or they will have the outcome, a bad outcome usually, or something. Okay, and when I treat them, the probability is higher or lower. Okay, if my treatment is effective, they should receive that the outcome should happen less. Okay, when my treatment is harmful, the outcome should happen more. Okay, if the and it depends on if the outcome is negative or positive. Okay, so what is the difference between this and the 2x2 table we usually talk about? Okay, here actually there is a 2x2 table, but for each time point. If we take the 0, we have 100% and 100%. If we take the 50 days, here we have 80% and 60%. Okay, so this chart just represents continuous 2x2 table on different days. Okay, so it's not that hard as it appears, but remember that for each time point, I can create a 2x2 table. Okay, actually the calculation for each one of the hazard rates for each one of these lines is really difficult because those are logarithmic functions and it will be hard to learn about them. Usually the computer calculates them for us, but hazard ratio for this point, for example, it will be the hazard of the risk of getting that effect, mortality or something, on the hazard rate of this point. Okay, and this is actually similar to a relative risk or an odds ratio because we are using the same logic, but the hazard is calculated differently. Okay, so till now, do you have any questions?
So the hazard ratio is like the risk ratio?
It's not calculated in the same way, but it is using the same logic. Okay,
Interpreted in the same way while I'm reading.
exactly.
Okay.
Okay, now we have two options, either continue with data entry, and I believe that we can do that in a third call, but if you don't prefer that, we can just stop here and do the data entry on Google Forms, and now we finished the presentation and we will just do some data entry and how to create Google Forms, access forms to enter data. So who agrees that we should continue with that in the third call? Just two. Who says we should end right now?
No, I was writing that I'm okay with continuing, so there's 3.
Okay, then I will call you in 10 minutes. Okay. Yeah.
Can we
goodbye.
have a shorter break?
A shorter can't. Longer can.
No, okay, thank you.
Okay. Bye. Okay. Do we have any question before we start? I will just say them again. We learned about the association measures, the most important ones. The first one is relative risk, the risk of receiving or having an outcome or a disease. The odds ratio, the relative risk are used for cohort studies, and the odds ratio for case control studies and those studies that are not representative of the population. But just consider it as this, like those are those which are representative, we use relative risk, and those that are not representative, we use odds ratio. Then we learned about the absolute risk reduction and the attributable risk. They are the same measure, and they are absolute risk, meaning that we have the minus sign, not dividing anything on anything. Okay, and the last thing is number needed to treat and number needed to harm. We use the absolute risk or absolute risk reduction and divide 1 on that number, so we receive the number needed to treat. The number needed to treat is the easiest way, because if I come to you and I tell you, you treat 3 patients, you save 1 patient from receiving that outcome or from dying. So this is actually really easy. Yeah, any question? Okay.
When we are when we are reporting our results, should we mention all these? Should we calculate everything and mention it?
No.
Or we can just
but we
calculate
just use
something.
one. Remember that we can't use odds ratio and relative risk in the same paper.
Yeah, I know, but like you said that the easiest way is to say how many patients I have to treat to save 1. So like should I mention the hard one and the easy one, or
you don't have to mention them all. You can just mention one of them. Okay, so if you are reporting relative risk or odds ratio, you don't have to report any other thing. And if you are going to report number needed to treat, then you do not need to report all the calculations and all the numbers before.
Okay, thank you.
Okay. Perfect. Okay, now we will discuss how to enter data, because this is actually a very tough thing in research, because how we enter data will just restrict our options in the analysis afterwards. So to enter data, let's say that I'm in the hospital and I have different medical records, and I know I prepared my questionnaire, as you remember from last session. How do I prepare my questionnaire? I need to capture every confounding factor. I need to capture all the outcomes I need to measure. Sometimes for example, when I'm calculating, for example, Barthel scale, and this is a scale for movement and physical activity, I can put in my questionnaire that I just put the total number, how much out of 100. But I can also put all the options in my questionnaire and I just tick them, and I tell Excel afterwards to calculate the numbers, okay? Which will be easier actually, because I don't want to just contribute into that calculation and receiving like a higher risk of mistakes. Okay, of course a computer can do it without any mistake. So the more detailed my questionnaire is, the better. And as you remember, there shouldn't be any question that includes like write the case presentation, or write the report for the echo, for example, or write something. The better is closed questions. Okay, so our options are 2 actually. We can do Google Forms, and when I'm collecting paper questionnaires, it's really easy to do Google Forms. Why? Because I go to the hospital, I collect all the questionnaires on papers, and afterwards I go back home and I create that form. And if we have different, or if we have several data collaborators, they can all get access to the same form at the same time and enter their patients. So I will tell you the outcome I'm going to put in my question, and you will tell me if I'm doing any mistake. Okay. So for name, it said that.
I just have a question.
Yeah.
How can I put all all the answers I collected from, for example, the university, into the Google form as answers, and the Google form doesn't accept only one email. Like if I re-enter the link, it shows me that I'm unable to complete the mission.
Yeah, okay, you can change that from here, okay? If you tick this collect email address, then you can't put, you can't fill in two forms from the same email, but I'm not checking this, okay? So I can fill like hundreds, okay?
Okay.
Okay, so for name, when I just write name, it gives me short answer, okay? Now I should know that the name I'm entering is not going to be analyzed, okay? Anything that I write down, like short answer, long answer, whatever, is not going to be analyzed, but I will need it. Do you know why I need that name?
For reconnecting with this the one who's doing this form.
Exactly. Or to know, no, Massa, actually, I'm the same person, but now here I'm entering the name of the patient. So I'm putting that in because if there is any mistake, then in the analysis, I found out that there is one outcome for one observation for that person that is not actually accurate or not that correct. So I take the name and I go back to the form and I find out the mistake, okay? But if I don't put the name, then I will lose the link between the papers and the forms, okay? Then the name should be required. I'll put another question, age. Okay, and it gives me short answer. Do you agree?
No.
It can be a list.
Why?
If I choose like numbers, it will be easier. I don't want them writing in here.
Exactly, because I will save time if I change that to a drop down, for example, and I will put 1 year, 2 year. Yeah, I will spend a lot of time now, but when I'm filling 1,000 or 2,000 patients, I will just tick, okay? And that actually saves keeping me from doing another mistake, which is if I enter a letter in mistake, by mistake, I entered an E inside the number, that will ruin the questionnaire, okay? So just choosing by clicking is much easier and it will keep the mistakes out. Okay, now I have, for example, interests, okay? And it gives me paragraph. Do you agree that I should keep it like this?
No.
Okay, what should this be?
Boxes or options?
A list. Multiple choices.
Multiple choices, like check boxes, right? Yes, actually, I did that mistake before. And what is the problem in this? Option 1, S, option 2, E, and option 3, T, for example, Z. Okay. What is the problem in here? Each question will give you one column. Okay, so this question, when I tick S and T together, okay, checkboxes are to tick 2 things or 3 things together. Okay, they will happen in the same column. Okay, so I will have in that column those with just T, and those with just S, and those with just Y, and then I will get those with the 3 of them, those with S and T, and those with T and Y, okay? And this is a mix. I shouldn't do that. What should I do? What I should do is I use a grid and I put Here, yes and no, or not sure, for example. And here we have the interests. Okay.
I make it like a question.
How will that appear? Okay, you can review that from here. That will appear like this. But when I take those, okay, look, it gives me a column for each one of them. And in the Excel sheet, you will find that for S, you will have yes, no, not sure. For T, you will have the 3 of them. And for Y, you will have the 3 of them. Okay? So, and this is actually what I want. I don't want them to be in the same column. Okay? This will save me a lot of time because if they are in the same column, I will just consume a lot of time to separate them again.
But they are separatable, right? Like there is a way to
separatable with a lot of time, with a lot of work.
So
Okay.
it's like you created more variables, right?
Yeah, I created more variables, but each variable will answer one question. Is that person interested in S, in T, or in Y? Not mixing everything.
Okay.
Okay? Yeah. And do you have any question that you think is not answered by one of those types?
If I'm asking about the place they are living, we can use like
options.
other, yeah.
Okay. For example, for places, for example, when I do a research about Syria, I put all the governorates and the central city of the governorate and the rural part of this governorate. Okay, that would be 28 options, but that will save a lot of time. Okay, because if I just keep it as a question with an open answer, you, for example,
I might have like
will write the governorate in Arabic, and I will put the governorate in English, and Excel can't mix them, can't say that those are the same. Okay, if you put an additional space, that will be considered as a new option of that variable. So I will need to do them all again. Okay.
Okay.
Okay. We have different other options, but we don't use them that much. File upload, for example, if I have a CT picture or something, but those are the most common, and the multiple choices, as we say, for example, for multiple choices, we can say that gender is multiple choices, and don't add other. Other just brings the question back to be an open answer question. Okay, if there is something confusing about this question, just put another question after that and name it note. And just if there is something special about that person, for example, for gender, you will write down something and note about it, and you will remember that when you open the Excel sheet, and you will correct the mistake. Okay. Okay. Then we know when, and where to use Google Forms. I need internet. Many people can enter their patients at the same time, and we can get some representations of, for example, let's go. Okay. I will go to one of the old workshops, and for the responses, you can find here some representations. If you don't want to do any hard analysis, that will be the copy that is linked to the Google form. And remember that you shouldn't change the Google form after you entered some patients. For example, I entered 100 patients and then I found out that there is a mistake. So I went back and I corrected the mistake. I added another question. That will make this Google sheet appear terrible afterwards, okay? So don't change, keep it. If you think that there is a mistake, try to solve it in another way. For example, adding a note in the notes section. Just keep a notes question in each one of your forms for additional remarks. For example, in the future you find out something else that you need to take as an outcome and you use that. Okay. Do we have any other options?
Sorry. So you're saying that I should always add a note section just in case?
Yeah, just in case. I found out that there is something that I should need, that I should add to my questionnaire. You can't add a new question, but you will use that notes section to put your notes in a special code. For example, you have 3 data collaborators. You send them, just copy this code and put it in the notes if the patients have that disease, and copy this code and put it in the notes if they do not have that disease. Okay, then you will get your answer and that column will not be mixed. Okay.
Okay, thank you.
So you use it as an option, but just to keep like a spare question for you. Okay. What else can we use to enter data? We can actually use Access. Access is more professional and it is used in different research projects, but it's not actually common among medical doctors to know how to use Access. Okay, let's create a new database. Okay, the database will appear like this, and I'll just tell you about the basic stuff in that Access database. Actually, in Access, we have more options than in Excel, okay? At the end, if I have a Google form or an Access, I enter my data, but afterwards, I will take them, I will export everything. I will save that or export as an Excel sheet to enter them to SPSS, to any other analysis program. So for here, you find out that there is that column that you cannot edit. And what is that column? Actually, it gives numbers to your patients, okay? And this is truly important. That will be automatic for Google Forms. They will give them numbers in an Excel sheet, but here you do not have numbers, so they give them numbers, okay? Why is that number important? After I get my Excel sheet, I sort them in a different way. I sort them those males alone and females alone, but I found out that there is a column that is missed and I forgot to add it. So how should I add that column to my database without mixing everything? So I go to that Excel sheet and I sort them according to that identifying number, and I go to the other one, to the source Excel sheet on Google Forms or in Access, and I sort them according to the identifying number, and here I have them aligned with each other. So I can copy from one database to another, okay? But if I don't have that number, I don't have any other option to just recognize who is that patient, okay? I can't, for example, if I have the names, I can sort them according to the name, but for example, if I have 2 patients with the same name, they can be sorted like this and they can be sorted like this, okay? But they can't have the same identifying number. Okay, so here I entered some data, and it is giving them like field 1, field 2. What is that number? What is the meaning of that number? It is a variable, and those are the observations. If you try to enter any letter in here, it doesn't allow you. Okay, and I will go on. Okay, so what are those lines? Those are observations. Those represent patients. And what are those? Those are variables. Okay, let's make that a numeric one. Sorry, yeah. Okay, now I have that, and this is actually similar to an Excel sheet, but I can go to here to view. What does that mean? I will save that table and I will go to view. It says field 1, field 2, field 3. Okay, here I can't enter data, but I can define that field. I can tell that this field is gender, this field is age, this field is interest, and so on. Okay, well, what can I do in here? Here I keep it as auto number ID because this is the key, this is important. I will keep that. For gender, what should I use out of those? We have short text, long text, and we shouldn't use those. We have a number, okay? And here, for example, you can specify the number. You can tell the number should have 3 digits, okay? You can use all the options in here. And for example, if you need a default value, okay, if I miss that, if I miss gender, for example, for one patient, what should it be? Okay, for example, let's say not in gender, but for example, in interest. If I miss interest, the default value can be no interest. Okay. It doesn't accept because there is an option that is activated for this variable. I will find that out when we come to this. Okay, then for gender, I should choose lookup wizard. Why? Because I need options, and to make the options happen, I will need to use this. I do not have options already, so I will type my values. I will write males and females. Okay, and here I can limit them to the list. Okay, I can tell the gender you can't choose anything that is not male and female, and I can allow multiple values. Okay, and we say that we shouldn't use that option. Okay, make 2 columns, but do not use multiple values in the same column. Okay, when I finish that, I will go back to the table from this button in here. Okay, I will save. Okay. Why did Access deleted the data in those 2 cells? Because I entered something that is not male and female. Now I can put male in here. I did a mistake because I won't use that. Okay, I will go back to view. What is the mistake in here? Here you can define, for example, the length of the variable. You can limit to the list or not, allow multiple choices, and all the options in here. And here you can change to the other types of data, the decimal, double, single, long integer. It means syntax. It means like typing, like letters. You can make the cell required or not. Okay, and you go, you save. Okay, now it is corrected. There was a mistake. Okay, and now you find out that this is a table and you can extract in the same way. For example, if we go to view and choose the age for age, I have the number and I make the number and I will choose that this should be required. I can tell them how long should be the that number. For interest, I can keep it like short text. I can put any other option. I can make yes and no. And now you can see that interest is now ticking. Okay, so how can I use Access as a form? After you enter your questions, you will go to create and form from here. Okay, and for that form, you can change the appearance of that form and you can view it. Okay, now I can view the form. You should close the table in order to be able to enter in that form, and it is similar to a Google form. I enter a number, enter the gender, I enter the age, that's not interested, and I go to the second record. I enter the number, and I go to another record. Okay, and so on, and I go to the table after that, and I will find the data I entered in here. Okay, so here we have 6. I will enter a new one. I will enter patient number. This is a new, and this is the button in here to choose a new patient. Here you can choose the gender to be age 3, interested, and go on. Okay, when should we use that option, Access? When I have my laptop with me during data collection and I don't have internet access.
Internet connection.
Okay? Or I don't want to save patients' data on the internet. Okay, I can keep my laptop in a safe place, but I can't like guarantee that my Google account is that safe, because like confidentiality is super important. So Access is a good option in here. So we have those two options for data entry, and we knew how to put the. Of course, that will be not that won't be like this. For example, I can show you one of the forms. You can ask me a question till I show you another example of an Access form. Do you have any question about data entry?
Can I use Microsoft Yeah, please. Please.
Can you use Excel?
Can I use the Microsoft Excel? Yeah,
Yes,
for
actually,
offline users.
yeah, you can use Excel, but it won't allow you to use forms to enter data easily, because if you see here in a form, I can't mix the data. But in Excel, with one mistake, you will delete 3, 4, 10 patients, 1,000 patients, whatever. Okay, here it is more safe. You don't open the table, you preserve the table safe, and you are just entering the data. And when you complete that form, when you will see that form, I will go to. Okay, in that form, you save your data away from your